Mm. All right, we are live.
Oh, cool. That's
Hi everyone, I'm really excited to interview Professor Yasu Furukawa. He's an professor of Computer Science Department at Simon Fraser University. He did his PhD in Computer Science from University of Illinois and Bachelor's in Computer Science from University of Tokyo. Today we'll be discussing the process behind his work. He has been published some incredible work in our domain, and I'm personally fan of Housegain Plus Plus, ConMPN, but there are a lot of other research papers he has published as well. So today we'll get some high level overview about his process and research work. So thank you, Professor Yasu, for joining.
Thanks for the introduction. I'm also really excited.
So can you tell us about your background, where you grew up, and why you chose to study computer science?
Oh, that's a nice question. So I grew up in Japan, a city called Kamakura, near Tokyo. So I did undergraduate at University of Tokyo, and at that point, the department chair or the head of CS in University of Tokyo was famous person who studies OS, operating system. It's more like a father or mother of virtual memory. He had a very nice speech for all the students who are trying to choose a major. He had a great speech and decided I should go to computer science. That's the future, which was kind of a true. CS is very important now. So I had the right choice. And so I kind of like computer vision, maybe because there are images and videos. I was not happy with having, say, results table. Number go up by 2%, 3%. Not really. I didn't find exciting. I more want to see images and nice cool results, which I can show to, say, my family members. They can appreciate, understand. So my background started from a computer vision task, which is reconstruction, meaning raw sensor data to some 3D geometric representation, mesh model, depth map, or CAD model. So I've been working multi-view stereo when I was in PhD at UIUC. This was very successful, used in many company digital mapping, visual effects. But I was more interested in CAD-based geometry reconstruction, meaning that the model which you can manipulate easily by hand. The polygon mesh, a depth map, we have the million points for the object. We can't really edit or do anything. It's very difficult to use. But CAD model is something which we make or which we kind of feel when we look at the scene, we perceive. So I like to go straight from sensor data to CAD model. That was really my core background. And on the other hand, or in graphics domain, generation is another big area. This is more about tool for artists, for architects, for the floor plan case. So from nothing to some realistic model. So this is our problem where answer is not unique. Anything as long as it looks good, that's an answer. The construction is a task where you have only unique answer. That's the only answer you have to get. That's how you measure performance. But I was interested in, I didn't really do generation tasks, but since GAN was making revolutions everywhere. So I got interested in maybe use GAN for something, for cat-like model. So that was my entry into Housegain.
Oh, I see. That sounds very interesting. And even I am from UIUC. So, like, is there any particular memories about your PhD journey which you would like to share?
Oh, yes. So maybe the very first, so even my probably the most famous work is called PMVS multi-view stereo. And when I first started, my supervisor, John Pons, so he's still another student was working on the recognition task. So Lana Lazbenik, she's also a faculty at UIUC right now. She was also my senior member of the same lab. And their group are doing recognition using some 3D representation. So one of his Jan students has some 3D model for recognition, which looks very good, but a very new way of doing reconstruction because he was doing recognition, not reconstruction. So Jan somehow thought that maybe that's the way to do reconstruction. So it kind of took over then throw into a reconstruction system, which is kind of different from the others, but ends up working very well. And also a very nice timing to do. So also maybe I was happy. So Jan, he has very not narrow field of view, he has very wide field of view. He knows what's happening in the world. So
Hmm.
that's when the internet vision is kind of exploding, meaning digital cameras are getting better and better year by year. So more pixels than what's happening in 2004 or 3. The cameras are getting better. So anybody can take very good images, only a few $100 to get a camera. And also internet storage is exploding. So people just take images and upload, which is common sense right now, not really back then. So digital imaging has really exploding. And then we have access to much easily high resolution content images. So results also get higher resolution, better and better. So I was kind of lucky timing to join, but my supervisor knew that's going to happen. I was given a problem with the right timing to solve the right problem. That's why I think it was very successful, and I was really happy.
I see. How about the cold in at UIUC, like Midwest?
Oh yes, yeah, it was cold. But well, I was from Tokyo, so it's a big difference, big change from the one of the biggest city in the world to the nice campus town. Well, maybe I didn't worry, didn't complain much about cold. Like rainy weather. Now I'm in Vancouver. It rains a lot. I rather prefer cold but no raining. That's better for me. So I didn't complain too much.
I see. I'll just share my screen
Yes,
for a second.
yes,
So, as we see, like you have a list of amazing publications, like right from Roofgan, Housegain plus plus, and I couldn't list all the amazing work you have published. So, can you like share a few of the key highlights of your research work till date?
yes. Just a second. Somehow, my computer starts behaving a bit weird. So let me switch to the other machine. I was expecting this to happen and just happened in the first 10 minutes. So I haven't seen your screen yet, but I guess you're showing the work from my beginning, from my PhD.
Yeah, I was just sharing like your website and like
Yes, thanks.
the
Yes.
publications. Yeah.
So I just switched my computer now.
Hmm.
Let's see now. Yes. So probably maybe should I start from the past or the future? I wonder which one do you prefer?
So like yeah, maybe the past, like how the work was evolved and your research interest grew.
Yes. So probably then I should start from there's a paper called Manhattan Stereo. This is 2009 or 10. This is my very first work I did when I was a postdoc at UW in Seattle. So after finishing my PhD at UIUC, I joined the group at UW. Supervisors are Steve Seitz, Brian Corliss, and Rick Zelsky, all the famous people in 3D vision. I was really happy. So this is my first problem for CAD-like reconstruction. So UIUC work is about the dense reconstruction. I want to make my model as accurate as possible. So I want to throw in more polygons, more 3D points to make things accurate as much as possible. So not human editable. It's difficult to utilize, say by architects or some artists later. And this is the first projects with some architectural prior. So when you look at the room, oh, wall is a plane, not like 1 million points. And wall and wall share the edges. So this is a kind of a way to model how will we perceive a scene as a human, as opposed to say depth camera. And I feel like actually after this project, I have immediately started this CAD-like inverse CAD style reconstruction task. And I have been still playing around my research interests, starting from what I was given by the Steve, Brian, and Rick. So Steve, Brian, Rick, I guess had the thought inverse CAD is cool. So dense reconstruction is nice, but it's not human editable. So my CAD-based reconstruction is very interesting as a broad application actually. So this is a point where I was really given the seed of all my research interests and inspirations. And after that, maybe ICCB 2009, reconstructing building interiors from images. It's kind of a Manhattan World Stereo plus plus, but very nice videos. In my view, this is maybe one of the first work to show that the street view style visualization work for indoors with a very high quality. So back then, street view was mostly outdoors and not very nice. And this is the first work to show indoor navigation can be really realistic. Maybe you see Matterport, the company, which is an indoor scanning and visualization. That experience, that level was first demonstrated automatically here. So then after this actually, I went back a little bit to large scale reconstruction. So Roman project at UW. So internet, you can download million images from internet. Then you can reconstruct the entire, say, city, that project. So again, back to density construction. But the internet vision was exploding, meaning everybody upload photos on the internet, you can download, access huge amount of image on the internet. This is really the start of that like internet vision research. So I can go into that. Then, but I guess come back to the CAD reconstruction after Rome. So maybe if you scroll up, the museum reconstruction, reconstructing the world's museum. This is with my Google intern, Jiang Shao, best student paper award at ECCB. This is the indoor reconstruction from the laser scanner. But the final model is actually the CSG model, can CAD-like model, which you can manipulate easily. So that was the, I guess, kind of back to the CAD reconstruction. Sorry, I just realized that my power plug was off. So this was the reason why it stopped working. Yes, got it. Then the next one, 2014, the piecewise planar compact. Yes, this is using the real production data from Google. So this is also gives you the CAD-like 3D model as a reconstruction, and also the nice tool, but using the real production data. Excuse me. And this is kind of maybe similar to the floor plan reconstruction. We get the model which looks like a floor plan at the end. And so if you go back to this one, well, maybe the next big thing is if you scroll up a little bit, Rasta to vector, actually one row up, or maybe two rows up, is Rasta to vector. Yes, this is kind of in my view milestone. This project was specific to Japan. So Japan, they already good database of floor plan images for many apartments, mostly apartments in Tokyo, and they are in JPEG format. So we don't know how many rooms, what's the connection. So if you want to make the accurate price prediction for this unit, or if you want to just list how many bedrooms, or you want to provide more rich information, you cannot. So in Japan, there's good database of floor plans. You want to just vectorize so that you can do more interesting study or analysis of the data, which is different from, say, USA or other countries where I think more than 90% of houses, roughly that ratio, do not have floor plans, say in other countries, or maybe in most emerging countries. They just don't have such a database. So it's a different issue. But this is for Japanese market specifically, you want to vectorize. And this is a combination of deep learning and some optimization. But this is, I think, the very first this inverse CAD style reconstruction project which become useful, meaning production ready, or having used for production actually. So maybe real deep learning helped us. After Manhattan World Studio, have some numbers of papers with just inverse CAD cell reconstruction, but usually not successful. Meaning paper is great, but people cannot use it for production. And after maybe 7, 8 years, this paper is the first one, which is CAD-based reconstruction, but production level quality. So I'm very proud. Chen Liu, my student, he's now at the Facebook Reality Lab. He pretty much his all ideas to really execute. So also yes, also Jajan, he's now a Stanford faculty, and then Pushmi, he's now a DeepMind. He did the AlphaFold. So all the great people are
Oh.
together for the project. So after these, maybe the next one is a FlowOn. Again, same Chen Liu, my student did it. This targets the other countries, say USA, or say emerging countries where you don't have a database of floor plans, even JPEG images. You have to go to a house. This project was using the Google Tango phone with a 3D sensor. So you go to a house and walk around with a video camera. You record LGBT videos, then turn that into a floor plan. And the pipeline is very similar to the previous vectorization project. Some component-based deep learning system followed by optimization. So deep learning alone cannot really achieve. Optimization is still very strong. So it has to be a hybrid system. And this one is also, yes, the production quality. Again, thanks to the deep learning. So another project which I'm proud.
Mm-hmm.
So yes, and then we have yes, FloorSP ICB 2000. This is kind of beta version of FlowOn. So still 3D point cloud as input, then converting into the floor plan. Again, just beta version, and people can use for production. So very good one. Again, the key thing was not Convenet. Well, Convenet, we use Convenet, but the new thing was the fairly complicated optimization engine. So it's, again, hybrid system, we have to use both. Convenet alone is very difficult. The deep network alone is very difficult to infer certain topology structure, the graph structure. It's very difficult to do by deep learning alone.
Mm-hmm.
So maybe before, yeah, now we finally reach the Housegain. So Housegain, there are 3 papers, Housegain, Housegain++, and also CombMPN. That's the very first paper. So maybe CombMPN is the first one. So this is kind of our attempt to remove optimization from the vectorization procedure, but still not easy. I think if you really compare this against the other system, which is hybrid of Convenet and optimization, that may be slightly better. This is not bad, but maybe difficult to win over. It's very difficult. But this is less hacks because optimization is very difficult to code. Lots of hacks and parameters. This is easy to reproduce. In that aspect, this is big advantage over the optimization. So this is a special kind of a graph neural network with the convolution-based message passing, and very effective for doing kind of topology inference, graph structure inference with a fully end-to-end manner. This was kind of the first project which we didn't think about actually GAN or generation. This was the reconstruction paper, a kind of replacing the FlowOn by this. This was more like intention. Then finally go to the Housegain paper. So this paper is maybe the first generation paper, meaning generative model paper. Everything else was reconstruction and something else. The very first one to tap into the generative model. So this is again, so we have a generator and a discriminator, but the core engines, generator and discriminator, maybe the next figure, system figure, there should be, I believe, a system figure. Bit maybe sorry, not that one. Yes, so a bit complicated, scary, but basically we use CombMPN for the generator and CombMPN for the discriminator. So looks scary, but actually very simple. So in terms of probably novelty, maybe combining the GAN with this special graph neural network with the special message passing. Then for floor plan generation was new. So technically, in our view, maybe not very new because we knew the CombMPN, which is very good, putting together. So kind of very natural to put things together. So there was no kind of no surprises in doing this. Kind of straightforward. If I think about the task, This is the one to solve it. Given the task, this is straightforward. Boom. Although making things work was harder. This is again tricky. So the student Nelson Nawata, he's my student. He did the Housegain plus plus. So he's a great hackers engineer. So he made it work. So this is the the very first generative model paper. So the last one, the Housegain plus plus, finally. So Housegain was actually nice, and people kind of love it. I guess we put some interactive application demo video on LinkedIn and more than 10,000 views. So quite a bit of interest, but it was not working well actually. We did a bit of post-processing to hide the fact that the actual output looked corrupted and not actually very great. We kind of hid it. Also, there are other issues that we didn't add a door in the house again. And so there are certain issues, and we resolved everything by in-house and plus plus system. And this paper is more like, to me, system contribution. Is indeed much better. Although technical contribution was mystery. In one of the workshops, I guess Mayu, you were also at the workshop, CVPR. I mentioned for this paper, the technical piece, we don't really understand why this works better. So it's a magical trick in training again, similar to the self-supervised masked language model. Back then, when we wrote this paper, we didn't have this understanding. So this training procedure, special GAN training procedure, is similar to the masked language training for the bird and the transformer thing. But now I understand very similar. So when I present this paper, I talk about in that context. But this paper doesn't talk about. So when you read it, you don't see the insight. So maybe you should better go to the talk I gave at the workshop CVPL this year. But there's a very, very simple trick on training, which Nelson just tried without thinking too much, but just immediately changed results. It's more like 1 week, he did it just so well. And we couldn't really understand why. We spent really maybe 1 or 2 months trying to really see why this works, trying to apply other problems, other generative model tasks. If this idea would work or not, we couldn't really come up with a conclusion. So at one point, we trying to have a paper trick which influences many generative tasks, not just floor plan. So we gave up. Just come back to this. But system-wise, it really works well. So that's why we have the online demo page, housegainpp.com, which anybody, yes, thanks. Anybody can come and play around because we think this really works well. So that's how I kind of started from the Manhattan World Stereo to reach Housegain plus plus this year now. Sorry, it's a little bit long to talk about all these.
I think it was quite inspiring to see like the whole journey of your research work, how you started from deep learning work to how like it was organically evolved, where you did con mpn and then it was integrated in housegain plus plus. So at now looking back I can see like connecting the dots which led to this. So
Yes.
it's great. So my next question is, can you describe like the roles and responsibilities of different people involved in either housegain or housegain plus plus, and what was the duration?
I see. So the maybe Housegain, the 3 papers are involved, the CombMPN, core piece. So I put 3 papers together to talk about the kind of how much time we have to put in to make things work. So CombMPN was very hard actually. It's very difficult to make it work. So Nelson was the one who really spent all his efforts. So probably 1.5 or maybe more than 1.5 years to publish, which is kind of a slow in the days of deep learning. When I was a student, 1 paper, 1 year was great, but now maybe not anymore. But the right now this year, he spent 2020, 19, spent more than a year and a half easily to make it work. So we basically tried everything possible using non-convenet MLP. Uh, the, the nerve style used the MLP or convenet or graph neural network. We tried everything to
Mhm.
solve this inverse scatter reconstruction, and nothing really worked.
And the only thing it worked was this idea. So it took a long time to reach this idea. It's natural, but took a long time to reach this. So the very foundation was built here, spending lots of time. So after this, Housegain was, I guess, fairly easy. So again, Nelson was the main driver for Housegain. Although we started working with Autodesk research for this project. So probably Chin Yi Chen, I think that's his last name. Uh, so Chin Yi was the Autodesk, I guess, leading the team there, and also his team members joined the project, and their team was very helpful to do this. So we are amateurs in the world of architects. What architects need, what construction industry needs. So we tended to write a paper which is cool as a vision paper, but useless. That's possible. So Chi Yi and others really drive me to the right direction. This makes sense. This doesn't make sense. And we have weekly meetings. And so the why Housegain was successful is really the team from Autodesk. They really know what they are doing, but they also really know all the technical pieces, the deep learning, the GNN or GAN, and that's why it works so well. So Housegain was probably maybe not half a year, but between 6 months or 9 months, I think, maybe that period. I guess went fairly well. Then Housegain plus plus again SFU. Also, yeah, Housegain SFU and also the Greg Mori at SFU. He is strong vision slash machine learning researcher. We are tapping the graph neural network with a spatial message passing with GAN. So we get some expertise from Greg on the project. And Housegain plus plus was again Autodesk and SFU. This was, I guess, fairly straightforward. After the March ICC by ECB deadline, I think we started. I think that we started. Nelson was busy with other projects. He started March, then submitted to CBPL in November. So 8 months, 7 months for Housegain plus plus. But there's lots of struggle. As I said, that the technical piece was a mystery. We don't know why that works well. So as a message, it's actually tricky to convince reviewers for vision conference because vision conference reviewers tend to like something complicated. If I be a little bit sarcastic, vision reviewers have to see unnecessarily complicated stuff to accept. So simple mistrust thing, which works very well, is often maybe a no for CPPL. So we worried about that. So we are trying to explore some technical pieces, but we couldn't. So there's something simple, magical which worked well. So we worried about actually submitting to CPPL, but the reviewers and AC understood. So we are very happy. That's roughly the timeline.
I see. And that's an interesting segue to my next question. Like, how was the process or initiation of collaborating with Autodesk? Like, did you like
Yes.
reach out to them?
Yes, thanks. Thanks for the questions, which I have to remember. So I know that the when my student Chen Liu was doing the vectorization, Rasta to vector. So it's the JPEG floor plan to the vector floor plan, or floor plan reconstruction, LGBT video to the vector floor plan. This is the floor plan. So in the areas of Autodesk. So I think Qin Yi interested in our work, so asked Chen to go to internship in some year. So that year that didn't happen. Chen already had a plan to do the internship with the other company. But at that point, maybe the first connection happened. Then, but the internship didn't happen. Then when we thought about tackling Housegain task, I think that's when we realized we need expertise. And Autodesk is the company who design software to making floor plans for architects. So I think that's when we reached out to them. Then the collaboration started. So I think that's the procedure. And typically, I really care about kind of a impact, meaning I don't like to write a paper which is technically fancy but useless. I'm kind of computer vision is one field. If there's a way to solve the same problem by using another way, I shouldn't do computer vision. The other way should be. That's what people should use it. So I really care about what computer vision can do, what other say field, what other things can do. So want to do what really matters. So for this project, I strongly felt we need help from the expert who really knows what architects need. So again, we reached out to Chin Yi. Then Chin Yi got some people, multiple people from the Autodesk. That's where the project started.
I see. And like there are so much research work going on in AI. Like there's some publication every day or every week and some state of that. Like how do you keep up the pace with all the
Yes,
research work going
yes,
on?
thanks. So in the past meaning few years ago, maybe 3 years or 4 years ago, I was kind of actually actively following the archive, maybe more than 3 years ago. Everyday archive. I trying to look at the title. Oh, this may be related. But quickly that becomes impossible because the volume goes up. So I'm not doing that anymore. For conferences, I guess in the past 3 years ago, I looked at all the title of the conference papers and then check, oh, this seems related. So let's read it. I did it. Now there are like so many thousands of papers every year. CBPL, ECV, ICCV, new RIPS, ICML, iClear, too much. So I'm not doing that anymore. So far, I rely on students or collaborators. So we have the Slack channels for each project. Whenever there's some paper which is related, people just throw in, oh, maybe some papers here related. This is my source for keeping track of papers. So that's how I changed how to follow the trends.
Yeah, I can understand. It's like it's not like there's limited time and so much to read
Yes,
and cover. Yeah.
yes.
So, what are some emerging trends in the field of AI or computer vision which AI enthusiasts
Mm.
in architecture should keep an eye on?
I see, yes. Thanks for the question. Yes, so yeah, with architects, so well, maybe this is not architects. So maybe so NERF is obviously a big thing. Rendering indoor scene is cool, but that's not really architects. So maybe I exclude that NERF bit. So for I think still the technologies for which one? Probably my interest. So my research, actually philosophy, does not go to mainstream. So this may not be a trend, meaning just what I care about, as opposed to what many others are doing. I kind of want to do what I can do. If there are common problem which others can do, I don't have to go to solve. So this is not the trend. Because maybe I did not really try to follow trend, so I can answer your question, but I can answer what I care about, what I think is important. So I think still this vectorization, reconstruction task is very difficult. So everything so far was 2D, at least from our lab. So 2D floor plan. But about the 3D, say, CAD model for the building, or maybe BIM, building information model. How to get BIM from images or maybe laser scanner, panorama 3D laser scanner. This is very difficult. And maybe because of lack of data. We had this discussion in one of the workshops we had with all the other researchers in the field. I think the kind of consensus, one agreement was the lack of data. So far, supervised learning is the kind of king still. So you have label input, you can learn how to go, but labels have to be given manually. So computer can just learn what humans do. That's supervised learning. It's still a king. And everything we have done so far is kind of like that. We have to have the answer by human. Then we learn. And of course, self-supervised learning is big, as you see in many papers. It sounds like a solution to many problems. Oh, supervised learning need label. So self-supervised learning may change it, but our case, not really. So the biggest issues of inverse CAD is, so we look at the scene, say my room. I interpret my scene as kind of CAD model. Again, one plane, one plane, one plane. I kind of see the lines between walls and corners, T-junctions. This model does not exist in the world. So say if you do NLP language, self-supervision for bird training is you hide the words and predict. So the sentences, the kind of special structured, the grammar-based structured sentences exist in a massive quantity, so they can do the task. Our CAD model don't exist much because that's how we feel, but we cannot capture image to get a CAD model. We have to manually make. So 2D data we manually make. It's still feasible, 1,000 floor plans. 3D data is very difficult. Also very expensive to ask architects. The lack of supervised data is very difficult. And people may say that, oh, why not self-supervised? That's difficult. But self-supervised for the image data, I mean, we take image, we train some tasks to predict the image again. They have images, but for our data, there's no such data. So we can even do self-supervision. So maybe the best we can do is putting some differentiable renderer style thing. So we predict a certain CAD model, then do differential renderer. Then that should match image. So this kind of thing, but this is very difficult. So we have to do something beyond self-supervision. Self-supervision beyond something very complicated, very complex structured model to image by differentiable renderer. This is very hard. So so far we have to rely on first annotation. And we don't have much 3D data, beam annotation, with corresponding sensor data. This really hurts us going to 3D. But we have now some data. This is the workshop also you attended. I attended the CBPL, the built environment workshop. So they have a challenge inverse CAD for BIM. So they have the BIM model for, I think, 7 or 8 stories, actually pretty big, large scale. They have the BIM model and the raw sensor data, panorama LGBD. So this may really open new thing. So this is open, which I think is important to go into. Then also a generative model on the other end, I guess is very still difficult. Humans make very complicated CAD model. And then the current trends are like the transformer or GAN. Usually CAD model, the people cannot use GAN. It doesn't work well. More autoencoder style, a VAE style generative model, transformer or the trend. But I think they are far from good. Still very far away from what humans do. So just have to maybe this task was not solved yet. We have to improve a lot. So to me, these two are my biggest interests in the domain here.
I see. Like, I think like even like as an architect, we feel like if there is a quick production and feedback from sketch to rendering, or like few images of rendering and 3D model conversion, which Nerf provides, that would be really improve our ways to test out new ideas and creativity. But also, like I was reading about it, that it's very computationally extensive. So real time generation is currently a challenge,
Yes.
but there are like tiny Nerf and other models coming
Yes.
up, which is reduced. But it's exciting.
Yes.
Yeah. How does a day in your life look like?
Oh, I see. Great question. Very busy with the family stuff. So maybe I shouldn't say this much because I feel like I'm not working too much. So in the days of school for kids, I have 3 kids. So one daycare, 2 grade schools. So wake up like a 7:15 ish. Then make lunch boxes for two kids in the grade school need lunch boxes. Daycare doesn't. So I prepare the lunch boxes, then wake them up and then feed them. Then pack them into a car and go. So 9 p.m. It's a 9 a.m. start for the 2 kids. After I go to daycare drop, then come back. So kind of my start is 10 a.m. not 9. So when there's meeting 9:15 or 9:30 meeting, I cannot make simply because the school 9 a.m. open have to be there and I have to come back with a car. So kind of 10 a.m. start. And also now it's better because of pandemic. So there's not much after school activities. But before the pandemic, or maybe in the fall semester, we start having all the after school activities. As many dads know, you basically become a driver. So some days, so 3 p.m. is the day, the end of the day. So 3 p.m. If there's no after school activities, the kids go to the after school. I forgot daycare style. I forgot the name. The place. They go to till 5 or 4:30. So they go there, and then. But if there's after school activities, we go pick them up, then take to the gymnastics or ice skating. I'm in Vancouver, so ice skating is popular. So maybe half of the time I can pick up like at 5 p.m. So maybe leaving my house 4:30 or 4:40. So picking up 3 kids and come back. And there's after school activities I pick up like at 3 or 3:30. So leaving my house 2:30 or leaving my house 3 p.m. Then picking and bringing to the after school activity place. Then in a car, maybe I use laptop to work. So then after that, I come back for dinner. So usually 6 p.m. I also often cook dinner or maybe rely on the takeout restaurant. Too busy. So maybe half and half. The cook, then feed them, let them take shower, bath, then homework for the kids, then cleaning dishes and doing everything, and people go to bed. I'm kind of done at 11 p.m. So pretty much 4 to 11 a family time, and I may try to answer on the phone, Slack or messages, but not like a dedicated time. Maybe after 11, if I have a power left, I try to stay awake, do some work, very exhausted. So I may just fall down. So it's very busy. Lots of time with families and other stuff.
I see. Yeah, it's it's a big commitment. Yeah. Um, what's coming next for you, if you
Yes,
can share? Yeah.
yes, I see. Yes, it's an interesting question. So I talked about the geometry, the constructions generation, but the other thing I am interested in is the motion tracking. This is you have the IMU, inertial measurement unit every smartphone. So using IMU only to estimate where you are, or maybe it's a combination of IMU or wireless sensor, indoor GPS style localization. So computer vision people do localization using images with the computer vision. So giving an image where you are, somehow it didn't make sense to me for many applications. So say you go for AR, VR, maybe AR, it makes sense. You have an AR goggle, you have a smartphone. So you put your smartphone into shopping mall, and then you take an image, you or the phone takes the image, so you know where you are precisely. So it can show you the virtual maybe shopping information or current sales item. You can put that's AR, and for that you can take an image. We have to put a display. But for most other usages, I'm shopping mall, pick up a phone where I am, where the nearest Starbucks. This one, I can ask the user to take a picture, get a location. It's more like pick up a phone and open the map, then you should know where it is. That must be. This is I learned from Google. People just so used to picking up a phone and know where you are. Doesn't work. If you ask, you have to take a picture. Then I tell you where you are. This system doesn't work. So it has to be non-visual for most cases of indoor GPS. So I was interested in using the non-visual sensor or anytime sensor. Basically, you're in the pocket, phone is in the pocket. It should be able to localize where you are, which basically meaning that the wireless technologies, Wi-Fi, Bluetooth, or IME. So combination of those non-visual sensor where you are. This is what I'm doing on the other end. So this is I'm interested in kind of to me a big thing, although not computer vision, but the lots of us actually AI, deep learning, in which I work with Facebook Reality Lab in collaboration for doing this. So that to me like a big deal. The other one is maybe this is typical, but the embodied AI is pretty big. Their workshop is humongous, huge. And I also agree with many others that now it's really time to go beyond the computer screen. And physically in the world, robots move around with a vision system, do some actions. So we are starting this embodied AI research. There are many simulations. We are not ready to buy a robot yet. So it's simulation based, but we're starting with simulation based. We eventually want to buy a robot to do something. I feel that's very important. So that's maybe two areas which is not about generation reconstruction.
That's quite interesting. Yeah, I think like both ideas are quite like sounds very promising. So my last question for the day is like, what will be your piece of advice for students or PhD or professors who want to do similar work or want to get into this area?
I see. Yes. So maybe what I want to say usually is say advice to people who want to come to say architecture, say AI for architecture or construction domain. For that message, well, maybe somehow instead of that message specifically to this domain, somehow my general typical message is whatever the field you go into as a researcher, it's more like again, this is a typical word you hear everywhere, meaning just trust your instinct. So don't follow the trend, and that's what I have been doing myself. So I've been interested in this inverse CAD style reconstruction, and I think I'm a minority in the computer vision. In a sense, most people go for dense reconstruction, but I have been just doing in inverse CAD style. But I somehow was not too worried. I think this is important. I care about. So I have been doing this, and usually people in computer vision, maybe I shouldn't say usually, they do dense. So they may not see inverse CAD important, but often very companies or people outside of computer vision have a good reaction to me. And also this indoor GPS project, uh, reaction from computer vision people are very bad because there may not be images in the data, but the people outside of computer vision reaction is very good. The indoor GPS, just one word, people understand is very important. So somehow I have been following what I feel is important. It's usually against what computer vision people think or follow as a trend. But so far, people outside of computer vision has a good reaction to me, which also leads to good funding and things. So I kind of believe in what I actually care about, then follow. So if that's the construction domain, that's great. You come to the domain. But for a researcher, that's what I actually do. Maybe that's what I learned from my postdoc supervisors. So UW folks, Steve, Brian, Rick, they do very unique research. I really learned. I kind of do what I can. So this is exactly what Steve said. I mentioned earlier today. I don't want to solve a problem which others are going to do. Because they do it. They solve it for the world. So I don't have to go to solve it myself. So I want to do which only I can do. This is what Steve actually mentioned in some of the meetings. So that's also my principle to follow. So that's maybe my general message for the researchers. For the specifically for those of you who want to come to architect slash AI, uh, maybe the pure interdisciplinary researcher is very nice, which actually I refer to Chin Yi, my Autodesk collaborator. He's really the key to all this success, and he understands both the hardcore AI and the true architects, the point of view. And pretty much he's essential for the research we have been doing. But they're very rare. It's very rare to see such a talent. So if you are doing architects, you're already in architect domain. If you want to come in, yes, I think that's great. Maybe Chingy is a good model. And if you're on the other end, you are doing more AI, it's really good to have somebody maybe from architect's domain to really gain expertise. That's really a great source of success in my view.
All right. I think this has been an amazing talk. I wish I could go on and on, but I think like we covered a lot of interesting aspect about your journey, research work, and advice. So thanks a lot for sharing your thoughts with us.
Thanks again for inviting. It's been very exciting and interesting.
Yeah. All right. Bye. Have a nice day, Professor Yasu.